So, you've probably heard this term thrown around, the AI tech stack. And let's be real, it sounds kind of complex, right? But what if I told you it's really just 5 simple layers? Today, we're going to break down exactly how a powerful AI system is built from the ground up. Let's get into it.
Because, the real question here isn't just about building another chatbot. It's about this. How do you create an AI that can tackle real, meaningful problems in the world? How do you actually go from a cool idea to a tool that's reliable, that's effective, that someone can really use?
Okay, to make this all feel a bit more real, let's follow someone on a mission. Imagine this researcher. Their job is to build an AI that can sift through, thousands of new scientific papers that get published every single month.
So to do that, they have to build what we call an AI stack. And honestly, the best way to think about it is like a recipe with a specific set of ingredients. It's the list of essential components you need to put together a working AI system. You miss one of these key ingredients and the whole thing just doesn't work.
So here's the game plan. We'll start at the bottom, the foundation. That's the hardware. Then we'll get to the brains of the operation, the models and data. After that, the conductor that pulls all the strings. And finally, the part you actually see, the application. And then we'll wrap it all up by talking about why every single one of these choices matters a lot.
All right, let's dive in. First up, a quick look at the big picture, the AI stack.
So yeah, this really lays it all out for us. See, it all starts at the bottom with the physical stuff, the infrastructure. That's what powers the model, the brain, and the data, which is all its knowledge. Then you've got this orchestration layer. Think of it like the manager, making sure everything works together so that the application at the very top gives you a great experience. So let's start at the absolute bottom with that foundation.
Okay, layer 1, the foundation. Infrastructure. This is literally the ground floor where everything else gets built. It's all about the raw power that makes the AI go.
So at its heart, we're just talking about hardware. But, and this is a big but, we're not talking about your average computer. Modern AI, especially these huge models, they need some serious horsepower. We're talking about specialized hardware, specifically GPUs, graphics processing units, that can handle just an insane amount of calculations. And what's cool here is that you've got options. It's not one size fits all. I mean, you could try to run a smaller model right on your laptop, but you're not going to get very far. Scalability is super low. Or you could go all in and buy your own servers, put them on premise. That gives you a ton of control. But for most people, the best bet is the cloud. You just rent what you need, and you can scale up or down whenever you want. Super flexible. All right, moving on up the stack. Next, we've got the real brain of the operation, the models and data layer. This is where all the thinking happens. When it comes to picking a model, builders today have an almost ridiculous number of choices. I mean, just look at a place like Hugging Face. There are over 2 million models available. That's insane. And it means you've got some pretty big decisions to make right from the get-go. So one of the first and maybe biggest choices is this. Do you go with an open model or a proprietary one? Open models are amazing for transparency and control. You can really get under the hood and customize them, and you're not locked into one company. On the other hand, proprietary models, they can be super powerful right out of the box, but you're basically trading that convenience for less flexibility. It's a classic trade-off. And then there's the question of size. This is another huge one. On one side, you have these giant large language models, LLMs, that have incredible reasoning skills, but man, they need that heavy-duty hardware we were just talking about. Then on the other side, you have these small language models, SLMs. They're way more lightweight, they're built for specific tasks, and you can even run them on a normal laptop. Pretty cool. Okay, but here's the thing, this is a huge catch. No matter how powerful your model is, it's not enough by itself. Why? Because most of them have a knowledge cutoff date. They're basically frozen in time. So for our researcher who needs the very latest science, that's a total deal breaker. And that is exactly why the data part of this layer is so important. So what's the fix? You build a data layer. This means you got to find your data sources. For our researcher, that's scientific journals, and then build these pipelines to clean up and process all that new info. And then you use this special kind of database called a vector database. You can think of it like a super smart library for the AI, letting it instantly find the exact, up-to-date piece of information it needs to answer a question. Okay, let's keep climbing. Next up, the conductor, or the orchestration layer. Right. So if the model and data are the brain, think of orchestration as the project manager. It's the thing that's directing all the traffic and telling all the different parts what to do to get a complex job done. So check this out.
When our researcher asks a really complex question, the system doesn't just guess an answer. Nope, the orchestration layer kicks in. First, it actually thinks and plans. It breaks that big question down into smaller, manageable steps. Then, it executes that plan, maybe using some tools to go search that database we talked about. And get this, it can even review its own work, critiquing the answer for quality before it ever shows it to the user. That's pretty amazing.
And all of that brings us to the very top of the stack, the layer that we, the users, actually get to see and touch. The face, the application layer. This is all about the user experience.
You know, a truly great AI app is so much more than just a chat box where you type something in and get text back. The interface itself might need to handle images or audio or other kinds of data. It definitely needs integrations so the AI's output can flow right into the other tools our researchers are using every day. And crucially, you need those usability features, things like citing its sources, letting the user make revisions, or providing feedback. That's what makes it trustworthy.
Okay, so we've just walked through all 5 layers of the AI stack. Let's pull it all together and talk about why getting this right is so critical. And really, it all boils down to this. This is the most important takeaway. Every single choice, from the hardware at the very bottom all the way up to the buttons on the user interface at the very top, is going to have major consequences for the final product.
This table just lays it out perfectly. Look, the infrastructure you pick, that's going to determine your cost and speed. The model and data you choose, that's all about quality and accuracy. How you set up orchestration, that affects what the system can actually do and how reliable it is. And finally, that application layer, that's what makes it usable and safe for people.
See, understanding how all these layers connect and influence each other, that's the key to making smart choices. It's how you build AI that actually works in the real world. So, the only question left for you is, now that you know what's inside the stack, what are you going to build?